Hello, this is Mr. Christopher. We're going to go through a problem on how to look at two different reactants being presented and trying to determine the mass of a product. So here we have 100 grams of sodium hydroxide and 100 grams of aluminum. Then how many grams of hydrogen will be produced? So in this problem here, the important information we're looking at is 100 grams of sodium hydroxide, 100 grams of aluminum, and we want to find out grams of hydrogen. To do this, we need to have the balanced chemical equation, which is provided in the problem. So here it says we have 6 moles of NaOH plus 2 moles of aluminum makes 2 moles of the sodium aluminate and 3 moles of the hydrogen gas. So in this particular problem, what we're trying to look at is how to convert the 100 grams here of the sodium hydroxide and the 100 grams here of the aluminum, and trying to determine the grams of the hydrogen that is produced. So to do this, we need to set up a magic number, x, which we'll put in front of all the coefficients. That x is the proportionality constant for the equation based on the numbers given. And then what we do is we place the molar mass in front of the x. So molar masses of sodium hydroxide is 40. Put that right here in front, 40.0 grams. For the aluminum, it's 26.98. And for the hydrogen, it's 2.02. Alright. So what we do first is assume the sodium hydroxide is the limiter. If that's the case, then the 100.0 grams equals 40.0 times x times 6. Okay? And then we solve for x. So here, when we solve for x, it's 0.4166, assuming sodium hydroxide is the limiter. Then we do the same thing for the aluminum. For the aluminum, 100 grams equals 26.98 times x times 2. So in calculating this, the x equals 1.85. Now in this particular problem, the one that is smaller is the magic number we want to use for the limiter. So because 0.4166 is less than 1.85, that's what we use for solving the last step of the problem. Since sodium hydroxide is the limiter with 0.4166, we then plug that in here to the hydrogen's information. So for hydrogen, 2.02 times x times 3 equals the number of grams of hydrogen that are produced based on the limiter. So we plug in our 0.4166, 2.02, 0.4166 times 3, and that equals the number of grams of hydrogen. This equals 2.525 grams of hydrogen. That is your answer.